All right, welcome to The Explainer. Today we're diving into maybe the biggest, darkest puzzle in all of science. We're talking about an invisible force, a force that's actively pushing our entire universe apart, and one that's going to decide how it all ends. So yeah, let's get right into it.
Okay, so to really wrap our heads around this thing, let's try a little thought experiments. Picture this. You're driving your car down a totally empty highway. You take your foot off the gas, right? You expect to just coast for a bit and slow down. But instead, your car starts speeding up, faster and faster. You're not touching the pedal. So what in the world is going on? What hidden engine is making that happen? Well, believe it or not, that exact same mystery is playing out right now, but on the scale of the entire cosmos.
Yeah, because just like that car with a mind of its own, our universe is accelerating. And the force that's pushing the pedal down, this thing we've named dark energy, it's not some small, trivial part of the equation. I mean, just look at this chart. It makes up a whopping 68% of, well, everything. And you know all the stuff we can see? The stars, the galaxies, you, me, this planet? That's just 5%. Think about that. We are living in a universe that is almost entirely made of stuff we can't see, can't touch, and can't even directly measure.
So this shocking realization, it didn't just pop up out of nowhere. It all started with what you could call a profound cosmic anomaly, an observation that just didn't fit. It flew in the face of the one force we thought we understood, the one force we thought ruled the entire cosmos, gravity. And what's so wild is the timeline here. See, back in 1929, Edwin Hubble showed us the universe was expanding. Okay, cool. So for the next, 70 years, the big question for astronomers was, all right, when is gravity going to put the brakes on this thing and slow it all down? Everyone expected it to slow down. But then, 1998 happened, and the data just completely flipped the script. The expansion wasn't slowing down at all. No way. It was actually speeding up. So now you've got this huge problem. To explain this bizarre acceleration, scientists needed a culprit, right? They had to put a name to this phantom force that was somehow overpowering gravity itself. And the name they came up with was dark energy. The easiest way to think about it is like this. You know how gravity is the ultimate pull, right? It's what clumps matter together to make stars and galaxies. Well, dark energy is the complete opposite. It's a push. It's this mysterious, repulsive force that acts like it's built into the very fabric of space, constantly pushing everything away from everything else. Now hold on, it is absolutely crucial that we don't get dark energy mixed up with its equally mysterious cousin, dark matter. Okay? They sound similar, they're both invisible, but they do the exact opposite jobs in the universe. Think of it this way. Dark matter is the cosmic glue. Its gravity pulls stuff together, forming the beautiful galaxies and giant clusters we see. Dark energy, on the other hand, is the cosmic accelerator. It takes those very same structures and pushes them apart from each other. Okay, so the big question is, if we can't see it or touch it, how in the world do we know it's even real? Well, it's kind of like being a detective at a crime scene where the culprit is invisible. You can't see them, but you can see their effects all around you. Astronomers have had to build their case entirely on this kind of indirect, but incredibly powerful evidence. And the first major piece of evidence, really this smoking gun that led to that huge discovery in 1998, came from looking at a very specific, very special kind of exploding star, a type of supernova that is so bright we can see it from billions of light years away. Yeah, these things are called Type Ia supernovae, but you can just think of them as standard candles. Why? Because they all explode with almost the exact same level of brightness. It's like having a whole bunch of 100-watt light bulbs scattered across the universe. If you see one that looks really dim, you know it's not because the bulb is weak, it's because it's super far away. It's a simple but brilliant way to measure cosmic distances.
And this is the whole ballgame right here. When astronomers pointed their telescopes at the most distant of these supernovae, they found something shocking. They were dimmer than they had any right to be. And if they were dimmer, that meant they were farther away than all of our models predicted. The only way they could have gotten that far away, in the time the universe has been around, is if space itself had hit the accelerator and sped up its expansion somewhere along the way.
But hey, a good detective never relies on just one piece of evidence, right? The case gets even stronger if you look at the faint heat left over from the Big Bang, the cosmic microwave background. The patterns in it only make sense if dark energy makes up, you guessed it, about 68% of the universe. And even the way galaxies are arranged in this giant cosmic web, that structure is being stretched out, bearing the fingerprints of this invisible repulsive force. So the evidence is pretty overwhelming. Something is definitely pushing the universe apart. The real mystery now is, what is this stuff? So let's take a look at the two main suspects in the lineup. Okay, so on one side, you've got the prime suspect, the cosmological constant. This is the idea that empty space isn't really empty. It has its own built-in energy, a constant energy that never changes. Then on the other side, you've got a more exotic idea called quintessence. This theory suggests that dark energy is some kind of new, dynamic field that fills space, and its strength could actually change over time, which is interesting because that might explain why the acceleration kicked in when it did.
And here's the really ironic part of the whole story. The simplest explanation, that cosmological constant, it's an idea that Albert Einstein himself came up with way back when. He just used it to try and keep the universe static in his equations. When he found out the universe was actually expanding, he threw the idea out, calling it his biggest blunder. How crazy is that? He might have been right all along, just for the completely wrong reasons.
But wait, there's a huge twist in the case. While the cosmological constant idea fits what we see pretty well, it opens up a gigantic can of worms. You see, our best theories are quantum physics. They predict how much energy empty space should have. And their prediction is off by a factor of 10 to the power of 120. That is a 1 with 120 zeros after it. I mean, that's not just a rounding error. That is, without a doubt, the single worst prediction in the entire history of physics. And nobody knows why theory and reality are so unbelievably different.
You know, figuring out what dark energy truly is, it's not just some abstract academic puzzle. The answer to this question will literally tell us the ultimate fate of our universe, the fate of everything. And depending on what dark energy turns out to be, whether it's constant or if it changes over time, cosmologists see three main ways this could all end. Let's run through the potential final chapters for our universe. Right now, pretty much all the evidence we have points towards one scenario, the big freeze. If dark energy really is just a constant feature of space, then the universe is going to keep expanding faster and faster forever. Eventually, all the other galaxies will be pushed so far away from us that their light can't even reach us anymore. They'll just disappear from our sky. The universe will become this unbelievably vast, cold, dark, and empty place. Just our own galaxy, an isolated island in an infinite black ocean. And that leaves us with a final, pretty profound question to think about. Imagine trillions of years from now. Any intelligent beings in our galaxy will look up into the night sky, and what will they see? Nothing. Just blackness. All the other galaxies will have been pushed beyond the visible horizon. They'll have no way of knowing that anything else ever existed. So what does it mean for us, right now, to finally be understanding the cosmos, only to realize we're destined for this ultimate isolation, pushed away by the very fabric of reality? It seems the greatest mystery of the universe might also be its most chilling prophecy.